So you're not here for rock music, you're here for events. So I'm Glenn. My day job, I'm running a cloud team in Knowit in Norway, which is the good part of Knowit. And unless you're happy with Knowit, then it is the same part of Knowit. So, and we usually have a slide here with a bunch of accomplishments of what I did and all the things that I've done. Suffice to say, I'm a certified rockstar developer. But I like to also talk about my failures. All the stuff I screwed up. And I screwed up so many times. I've screwed up over and over again for over 20 years. Now, I haven't done the same mistake twice. That many times, at least. But usually I learn from my mistakes. And failure is a cruel, but it's an effective teacher. It's like you go into a place like, I should never have gone in there. I'll never do that again. And I'm going to share some of the things failure had taught me and some of the things I found to work well to avoid failure. Now, you can reach out to me on Twitter. Please use the hashtag if you tweet here, and the organizers will be happy. That's always cool. People can find your stuff. But that is the easiest way to reach out to me, or I'll be here all day, all night, and tomorrow as well. So if you have questions, find me. If you have questions during the talk, raise your hand, and we'll go over time. It doesn't matter. There's only lunch afterwards, and none of you people need to eat anyway. It's always nice being the thing between you guys and lunch. It's a pleasant position to be in. See the anger, people get hangry. Does anybody get hangry? Angry when they're hungry? Yeah, okay. Yeah. Anyway, we're going to look at some concepts. We're going to look at some tools. We're going to look at some concrete examples. The examples I use are all from Microsoft Azure, since that's my home turf. That's my people. But the concepts are universal, and you find similar services in any public cloud today. So it doesn't really matter. It's easier for me to make the examples. Two definitions I'll be using. Cohesion. Things that belong together should be together. We'd like to have a strong cohesion. That means that the things that are together are the ones that belong together. If you have a low cohesion, things are spread out all over the place. The other word is coupling. Connections between parts of a system. So if you have a high coupling, you have a high number of connections between different parts. If you have a low number of couplings, there's only a few connections between parts. I'll use those words, so it's important you understand what they are. So, commonly a problem that we see is that we're building applications. What do we usually do? What did we learn in school? Well, it's the easiest thing to do. We fall back to that. If all you have is a hammer, you'll spend a lot of time looking for nails. Now, we do file a new project, build a nice solid foundation to build our app on. And even though you're happy with this, it's usually built to support this thing. And you'll suddenly find yourself building this thing. And this is one of the differences between physical engineering and software engineering, is that nobody builds a bridge and then goes, you know, I bet we could land an airplane on that. And this is how people end up with what's called the monolith application. As anyone see 2001, the movie? The black monolith, the big slab of something, completely opaque. You have no idea what's in it. It just does stuff. And why does this happen? Well, because when we change systems, when we add stuff to something, complexity increases over time. This is a natural thing. As time passes, complexity increases because we add stuff. There's physical laws that point to this being true. So what do we do? Well, we introduce what we like to call complexity-reducing measures throughout the project. And we like to believe that this is how our complexity looks. However, in reality, as a system grows, complexity increases exponentially. So that means our complexity-reducing measures are not really as effective as we'd like them to be. So what can we do about this? Well, if you don't do anything and you're just happy with small minor changes, your application suddenly looks like this. And this is a real application. This is not something I made up. This is a class diagram of a real actual application for Norwegian television. Now, this complexity is not only in your code, it's also with your people, with your teams. You have multiple teams that talk to each other, different points, different agendas, different requirements, different release cycles. All of this is adding to this complexity. So what are these complexity reducing measures? Well, one powerful thing is to start dividing the application up in multiple parts. You make what's called a distributed application. We have a little part here, and you guys can handle that, and you folks can handle that, and you folks can handle that. We find the elements with high cohesion. We put them together. Like this belongs here, this belongs there. And that means people can reason about something a lot easier, because they don't have to reason about the whole thing. They can focus on a smaller thing that belongs together. This can be very helpful in different teams. Each application can distribute individually, and so on and so forth. And then you need to decide how these different applications talk to each other. This thing needs that thing. It needs to tell this thing to do this thing, and then this thing has to do this thing, and this has to be in order, go there and there and there, and this one fails. And then this team splits their service in two, and everybody has to update their stuff, and somebody else needs to update how they talk to it, all that stuff. And is anyone familiar with this thing? Anyone been here? Yeah, so I see some nodding heads in shame. Well, what happened is you built what's called a distributed monolith. And it is not a good thing. You just made your problem worse. You have the same problems you had, except you just spread them all over. And you added network to your problems instead. That's one of the fallacies of cloud computing, believing that the network doesn't matter and it's always there, which it's not. So the problem is that we haven't reduced the coupling. We figured out the cohesion part, but we didn't reduce the couplings. We have hard couplings between every service. This service knows about this service, and this service, and this service, and so on. That is the part we need to fix. Now, the common way of making services talk to each other today is use an HTTP/REST interface. This service sends a message to this service, wait for a response, and gets an answer back. And that was also the topic of the song. People tend to give REST a bad name. You have services that whatever happens, they just return 200 OK with a JSON that says error equals true or something like that. Has anyone had those services? I like the ones that just return, if you send something, just return 200 OK and blank response. Content length, 0. And the error is that you didn't get a response. So we have to, what happens if this service is gone? What do we do then? Then we have to make retry policies, the network can be unavailable, the service can be unavailable. We have to do a lot of things to make sure that this service is, this communication is okay. And we have to multiply this by number of services. So this is where events come in. What are events? Well, in essence, we have our service, and it sends out an event or a message saying, hey, this thing just happened. And that's as far as this service goes. It just shouts out something. It's almost like me over here. I'm shouting out something. I have no idea if you people are listening or not. Some people are nodding their heads, so I'm guessing that's okay. But I can have a different service who listens for events of that type and picks it up. And when this event happened, when this fact is true, it takes an appropriate action. And I can have multiple of those services. We call these subscribers. And the beauty of this is that none of these have any knowledge of the other's existence. They simply do not know. They have zero knowledge of each other. Now, to be clear, there is a piece in the middle here. This is our messaging service. This is the thing that receives our messages, keep tracks of the subscribers, make sure that things go here and things go here. Oh, you want this one, you get that one and this one. And it acknowledges that the message was received, so my original service is okay. The publisher is off the hook. It is no longer concerned with what happens. The messenger took your letter and said, I got this. Don't you worry about a thing, bro. I got this. And you go, whew, that's that off my back. If one of the other services are offline, it will be delivered later. Delivery can be guaranteed. The whole thing is now asynchronous, as opposed to the previous synchronous REST. There can still be failures, Maybe the messenger service is down. Less likely. Often a more stable service, often more money is put into that to make it solid. And also, it's a smaller problem to have. So if that thing is gone, we only have to concern ourselves with sending messages still guaranteed to that particular thing, not 25 others. So this is a fire and forget situation, which we call, I'll just send something off. What if I want to reply back? That's, well, I can reply. Well, we can send messages in two directions. So I can send one message here, also containing a destination or a return address, and say, when you want to reply back to me, send me back a message in this inbox, basically. Now, to be clear, this is not without complexity. This is not something you do if you want to keep track of your own old Laserdisc collection or something like that. But the complexity is limited compared to the complexity in a large application. And also, the complexity tapers off quicker. It grows fast and then it just tapers off. The increase in complexity over time is a lot less. So since there's some overhead, but there is some overhead, you might want to do it for your small, simple application, and you might not want to start your application here, but you might want to introduce this later. Now we can also use the words messages and events. And these generally mean two different things. The difference is in the intent of the publisher. So if I'm publishing stuff, what would I like to happen? What should happen when I publish this? If I had, do I care at all? Do I have expectation of what should happen, what the outcome should be of me putting out this message? How should this be handled? Is it a command to be performed to do this thing? Should it start a workflow or something? If it has some kind of expectation of action to be performed, it is a message. If it contains, often if it contains the whole data, like here's some data, I would like you to do something with it, it is a message. It would contain information of some value. If the message was lost, that would be a bad thing. If you have a message containing information about a money transfer, that this amount of money should go in this account, if this just disappeared, people would be sad. I don't get my money. Some other people would be happy. I have more money in my account than expected. A desire to get a response back, like we talked about, that could also be expressed in the message. Now, this is different from the situation where the publisher has no expectation of what happens. It just publishes out a fact. This thing just happened. It doesn't even have an expectation that someone is actually listening. This could be an information. Its purpose is to inform. This fact is happening or has just happened. Customer was just created. I don't expect anyone to do something with it, but if somebody wants to, they're free to do so. We also separate events into different categories. The events about actions carried out and data points or stream events, which are a continuous stream of data. I'll do some examples of this later. So, for instance, the application, we had a customer was created somewhere. Somebody went in and says, "Ready, new customer. I would like to be a customer." La, 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 la. Fill it, save it, store it. The new customer is stored. All of this happens in this thing. And then it publishes the fact that customer created. Now you can have a bunch of services here. One service can pick this up and process the registration and send a physical welcome package to the customers, like, "Hi, welcome for being a customer. Here's your new t-shirt," or whatever. One service can check it out if it's eligible for a promotion that is currently running and add some stuff there. And the third service can do some registration or logging. It could, one of the promotion thing could be temporary service, just set up just for this purpose. Has anyone heard of the solid principles? Yeah. Chris has done a good job, I see. He usually does those. There's a concept there called the open close, where I can't remember, I never remember the exact words, but it should be open for change and closed for modification or something like that. Like, well, what does that mean? I should be able to change it, but not. Well, this is part of the open close. I can introduce a service to my system that can change the behavior of my system without changing the existing parts of the system. We can just put this service here, subscribe to an event, and I can do stuff. So my system has changed the behavior, but the actual system, existing system did not change. Questions on the concept so far? I've either been incredibly clear or incredibly obtuse. Oh well. So what tools can we use for this? In Azure, we have 3 different messaging services. We have the Service Bus, the Event Hub, and the Event Grid. They all have some specialities, they all have some use cases. The Event Hub is for the data points. It is designed to ingest a continuous stream of data at enormous scale if you want. That's all it does. It is a place for you to shove events at an incredible rate, and it will take it and say, I got this. And it can have subscribers to these events, and it can make sure that all the subscribers get a complete stream of these events in the right order, and they don't miss anything. If one subscriber is offline for a while, it can come back and can continue where it left off and everything. It does this incredibly well. Now, in Event Hub, the individual data points have little or no value. It is the stream of data over time that has value. So for instance, we could be interested in trends, change rate, sudden changes. If the temperature in my house goes from a balmy 24 degrees to 70 degrees, something is probably wrong. I would like to know. If my power consumption for the last hour, I can calculate that, for instance, things like that. Event Grid are for business activity events. Things that stand on their own, not in a stream context, customer created, so forth. There is an assumption here that you might have a large number of events. You might have from different contexts, different applications, different types. So the subscribers should be able to work in parallel. The subscribers should be able to filter, or you can set filters to be very precise on what you want to receive. As opposed to Event Hub, Event Grid will push messages. So when something comes in, it can push it to the subscriber, which makes it ideal in some situations, especially with serverless. I'll come back to that. And then we have Service Bus, the grandfather and the Swiss Army knife of the collection, which is basically what the other ones are. Event Grid and Event Hub are both specialized versions of Service Bus. But it is, well, they too are focused on specific tasks and scalability and do that extremely well. The Service Bus has a stronger focus on transactions, rounding of events, hybrid versions, connecting on-premises services. It has more of a pull system. So it is, all of these 3 can do events. Service Bus is message focused very much. Event Grid is more business event focused. And Event Hub is event data series focused. That is basically their 3 different focuses. So, some examples. We have a whole load of electrical meters. They measure power consumptions in your house. On each meter, there's a little hand port, it's called, home area network, which will every 10 seconds output how much power your house has consumed for the past 10 seconds. It can even go down to a couple of seconds, every 2.5 seconds, I think it is. Now, we did this for a client in the smart home solution where they had a device on each meter that would pump these signals into an event hub. So thousands of houses, events coming every 2.5 seconds. This house has used this much power right now. We get that stream, we gather that stream, and we can use tools like Stream Analytics to do temporal queries saying, sum the energy consumption for the past hour, grouped by meter ID, for instance. And we'll get out a new stream that says that particular thing. Or we can add it to a database and stuff like that. That is the kind of thing you can use Event Hub for. When you have a large number of events, each event is not really useful. Well, we collect them and we can do queries upon them, or trends or analysis. In the same house, we can have a thermostat controlling the temperature. Now, if you set the temperature, we might want to register that as an event. The consumer set the temperature to 27 degrees. Likes it hot. We can take that message in. We can push it to a function somewhere that will gather that event, update some data, update some digital twin or whatever in the cloud, or some cloud-based state object. And then we can have a second subscription that takes this data, stores it in a data lake somewhere for analysis. And then we can have a third subscription that takes this off, this event, puts it in an event hub, feeds it to a different system. Now this was part of, there's more on the right here, where we would use these data, historical data from machine learning, because we would like to control, have you noticed how most smart houses are really dumb? When people, I have a smart house, what does that mean? I have a light switch on my phone. That's not smart. Smart houses want to make, so we want smart houses to make decisions for us, like I should regulate these things and control the electrical consumption and make sure everything's cheap and nice. That's a smart house. The light should be on right before I come home, not when I flick the switch on my mobile phone. So we have some machine learning stuff here, and all of these things are nice, and the thing is, I can now expand this without actually caring about anything from there. I have some more examples, but we're going to look at a bit closer on Event Grid, if nothing else, because it's the latest kid on the block. And it offers a few advantages. One of the advantages has a bunch of connectors that you can attach to it. These are pre-made integrations to different services. I can collect from subscription, container registry, service bus, media service, storage blob, different things that are pre-built, like I can just connect it. I can configure it up. And I can output to a bunch of things. I can output functions, webhooks. Let's take a look at that. How does that work? So here I create my topic. So AC, I can use this from the command line. I could have done it in the portal. It doesn't matter. AC event grid topic create, name, give it a name, TD blob. I get some data back. And then I can push my events somewhere. I need to specify where do my events go. So I have my topic. Now I need to specify where do my events go. When something comes into this topic, what happens with them? So I put up an endpoint, so it's a webhook, and I do event subscription create, topic name, the name of the subscription, and the actual endpoint. This is just a URL. This is a webhook. So what happens is that Event Grid will first create subscription. It will send an event to my URL. Now, to read these events, for these demo, when I made the slides, I used a little tool called the Azure Event Grid Viewer. If you Google that, you get to this page, and it has a nice little button here called Deploy to Azure. So if you click that, it will take you into the portal, and you will click Create, and it will create a web application for you. That web application will look like this, and it's a SignalR application that will just show incoming events as they go. So you can basically ship events to it, and it will display them for you. It's a really nice tool to have when you're debugging your events. And of course, you can just add subscription to existing events, so these can come in parallel with the rest of your business. Now, when you set up a webhook, you get what's called a validation event. The validation event has a validation code right here. You have to pick up that code in your web application and return it back as a JSON to the first reply. That is to confirm your subscription. So basically, your webhook has to say, yes, I would like to have these events. And once you've done that, you get your events. Now let's try to send an event. This is the topic endpoint on top here, TD blob West Europe 1 event grid azure.net/API/events. That is just a URL. I can take an event object. This is just JSON. It has some data to it. Record inserted in my app vehicles, motorcycles, make Ducati, model, Monster, which is a nice bike, by the way. And then I just post this to that endpoint with my key. And I get a reply back, 200 OK. Everything is fine. So what this means is that anything can use the event grid as long as it can do HTTP. I can send events from my command line if I want to. And of course, in the event viewer, I get my record inserted. In my vehicles, motorcycles, here's my data. That's my event. We can do it from code. There's an SDK for that. 4 lines of code. In reality, is only the last line that actually matters. Publish events async. Boom. That's my events gone. That's all I need. Some setup, and I can just publish events. So it's super easy to take an application or an existing system and start pushing events to event grid. It's super easy to receive them in a webhook. So it's really easy to connect different systems. Now, I said there was that was a custom event. Let's use some of the building blocks they have. So we have a file that's created. It's uploaded to Blob storage. From there, we get an event in Event Hub, and then show that on a web page. So how do we do this? Well, we have our endpoint. That is where we want the events to be sent. That's our subscription. I get my storage ID from a storage container and put that in a variable here. And then I create an event subscription, connect it to my resource, and then I send it to my endpoint. So with that command, I'm now connecting my blob storage to my web page through event grid. We get the validation event, of course. Then I upload a file to blob storage. Exit storage blob upload file, container name, name. I get an e tag. If you remember that e tag, you will notice it is the same e tag I got here. Then I get a notification that in my application that a file was just created. It was put there. It is 22 bytes long. It's a text plain. This is the URL to the app, or to the file. This is basically done with zero code. And we could add more events to this thing without bothering anyone. So for instance, if I upload an image to blob storage, I can have one little thing, resize it and make a thumbnail. I can have one little thing, extract the EXIF information from the picture and store that metadata somewhere. I can have one little thing doing machine learning to get a description of the image. I can do one little thing that can do facial recognition identification. And none of these things need to know that each other exist. Now, let's talk serverless. First of all, serverless is hyped. This is how you can tell this is a proper professional presentation. I have Gartner curves in my talk. Serverless is right up here on the innovation trigger, right in the middle there, serverless PaaS. It is on the hype cycle. Here we go. Right above blockchain. Some people, so the hype cycle is a progression of maturity of software concepts, and things that are in the beginning are considered to be, haven't been time to create a bunch of success stories. There's promising thing. None have really made something solid, something huge thing. Things might flood, slightly immature market, but it's getting there. Some people are skeptical of this concept of serverless. I hate the word serverless. You wouldn't call a taxi server carless. No, you call it a taxi. I hate the term serverless. I hate serverless. I hate serverless. I hate serverless. If you hate the term serverless, just wait till you find out it's not actually a cloud. I don't even know what that means. Random thought. I hate the term serverless. It's not running as a magical ether. There's still a server involved here. There's no cloud, just someone else's computer. I hate to break it to you, but there is a server in Azure Serverless. Well, I'm not stupid. I love these guys. Like they just discover some deep hidden knowledge that the common mass just simply missed. Whoa, there's a server involved. I thought it was running on somebody's toaster. Of course there's a server involved. There's even a lot of servers. The point is, I don't want to care. I put this on Twitter. Servers are a problem. Want someone else to care deeply about. And I was extremely pleased. Clemens Vastra replies, we do. He owns messaging in Azure. So he is the prince. He has designed the whole messaging architecture and all those things. He owns that part in Azure. So that's serverless. It's not having servers, it's not having to care about servers, right? So serverless is basically just a step up the ladder of abstraction. And of course, we can solve any problem in computing by introducing an extra level of indirection, except the problem of too many layers of indirection. So there's a nice story. Adrian Cockcroft. Anyone heard of him? He was the chief architect of Netflix at the time. So he knows his cloud computing. And this was like 5, 6, 7 years ago, I can't remember when. It was a conference, and he was explaining how they moved from disks of spinning Rust to SSD disks in their servers, like to flash drives. Does anyone remember when SSD disks came out, there was a lot of hubbub about limited number of writes and trim and all that stuff. And like, yeah, well, you can only write so many times to SSD disk, it will fail eventually. And so this kid, was a 19-year-old kid in the audience, goes, Mr. Cockcroft, yes. So what do you do with trim and smart and all that? How do you handle that? And this hush goes through. Oh, there's this 19-year-old really putting it to the chief architect of Netflix. And Adrian goes, well, I don't care. That's Amazon's problems. I'm renting them. So it was a pure business decision because they could go from like 500 IO ops for $1 to 3,000 IO ops for $3. It was like 6 times performance for 3 times the price. Like, done deal. Let's do it. And he went up the ladder. He stopped caring about stuff. So let's start with functions. FAS, which is a fun word to say. Functions as a service. Azure Functions is Microsoft's offering in this space. It is a function, take a little piece of code and just put it there, say, run this piece of code for me, please. And a function has triggers and bindings. You can bind inputs and outputs, and you can have functions trigger on specific things. And it has a bunch of these. It can trigger on things in blob storage, Cosmos DB, Microsoft Graph, Excel tokens, Microsoft Graph. It can trigger so much on Microsoft Graph, I even wrote it 3 times, apparently. But it can also trigger on HTTP, and it can trigger on webhooks. It is a built-in thing for webhooks, which makes it really useful with Event Grid. Some of these can be outputs, some of these can be inputs. Let's look at an example of how functions work. Here's a function name. It's called HTTP trigger. That's just the name of it. If we can, oh, that was too far. It has a method called run, has a parameter HTTP trigger. With the attribute HTTP trigger, I can get and post to it. It has authorization level of function, which means that I have to have a key to use this function. It is of type HTTP request message and has the name rec. And I get a log trace writer as well. That's basically all I need to do to make this function respond to an HTTP call. I have to specify a parameter that takes in HTTP request message. So we used this. We wanted to receive a HTTP call from a third-party vendor. The call contained an array of events that happened since the last call, because we had a smart house and stuff happened in smart house, and we pulled that in. So we pulled those events out and published on the event top. Now, of course, I could do file new project, write it out, add a controller, perhaps add some depends injection, add some code here, publish this. Or I could just write a little function that just takes a request and pushes it somewhere. Publish that. Here's a function that triggers on a new file in a blob. So blob trigger with a path, with the parameter, blob name. I get a stream into blob input. And I can use an out parameter, blob, sample images copies, blob name again, write to that, and I get a stream. So basically, all the infrastructure of connecting to the blob storage, finding the file, creating a stream, and then creating a new file, creating a stream for that, all of that work is handled for me by these parameters. All I have to do is write code that takes a stream, does some magic to it, and put something out in another stream. Now, this is a rather nice place to be. Now, the best code is the code you don't have to write. There is no bugs in code that was never written. But I can focus on putting my business logic in a function, make that completely self-contained. I don't have to write any plumbing code or infrastructure code, nor do I have to care about how this is served. I can just say, take this function, make sure it runs. Now, there's a couple of things to consider. Serverless does not cure cancer, nor will it give you a fancy house or take care of your cat on holidays. There's lots of things serverless does not do. There are certain app types that work better as function apps than other, and there's certain app types that work considerably worse as a function app than others. Again, we're back to cohesion. How can I make things that belong together be together? There's ways of doing this in functions. For some things, I won't get into all of that. But does it make sense to split in a different function and have some kind of separation between them? Maybe not. Now, here's an example of an event grid calling a function. So here I have a parameter again, event grid trigger, bind it to an event grid event. I can do event grid event.data, which would be my Ducati Monster data. And this is better than the previous example where I reacted to a blob event. Why? Because now I have less hard couplings between my storage and my processing code. I have an intermediate that will take care of this for me. So instead of having my function respond directly to my blob storage and have several functions respond to the blob storage, I can have event grid respond to blob storage and multiple functions respond to events, which makes it easier for me to move my storage around. It makes it easier for me to move my processing around. A more practical example of how this was used. And this is where functions really shines for me, is with integrations and between different systems, between the front end or the back end. I would probably not build like an entire ERP system. I would not recreate SAP in functions. I probably wouldn't build payroll system in functions on loosely coupled functions all over. But one place where it worked well for me was in the Smart House thing, where we had a little meter. It would push data to a cloud service, third-party vendor. We had no control over that. But they would push events to us. They would do it over HTTP. We had a function that received those events, made this into grid events, and published on event grid. Now, the event grid would take those events. We had another function that would subscribe to those kind of events and transform those events, because we had multiple third-party vendors. So it would transform those events to our domain-specific events. So we have on this side, we have our own events, and to the left here, we have the vendor-specific events. Now from here, we would have a function that picked up those events, store it in storage, would put it in the web API, update a state, would store it in data lake. Lots of things could happen there. We could also have things going back, saying that when you, on your mobile phone, used your digital light switch and turned the light on, it would send a message to update the state. That would send an event. The event would go out to multiple subscribers for different vendors. If the event was for a device that didn't match that particular vendor, it would just discard it. If it matched, it would forward it to the third-party vendor cloud, and it would update your light switch. The nice thing about this architecture is that, and to be fair, there's lots more on the right here. But it put a nice little separation between vendor systems and our systems. And introducing new systems or new vendors is just a matter of making three little functions. One for receiving events. Some had to be polled, some were pushed to us, different kinds. One function for translating it into our specific events. So if we had, for instance, batteries, we had different vendors for batteries. That would be converted into a special battery event. We had solar panels. We had gateways for switches and thermostats and heaters. And we'd make a third function for pushing events back. Everything else just worked. There were no changes, and they had no idea that a third-party vendor had been added. So I often like to think of functions as cloud glue. If I'm building a model airplane, the glue is a really important part. But it's not the important part. Nobody looks at a model airplane and think, wow, that's a really nice glue you got there. You use some quality glue here, I can tell. So it's all about crafting together a system and putting these things together. It makes it easier for me to build with Lego blocks, basically. Now, you can run Azure Functions in two ways. You can use what's called a consumption plan, which basically means you pay for consumption. You pay per execution in gigabyte seconds. That's an SI unit you haven't heard of. So it's basically a mix of how much memory you use and how long your function lasts. So if you use a lot of memory, you pay more. If it lasts longer, you pay more. But scaling and all that is no longer your problem. It is fixed. You don't have to care. That is the serverless part. There's problems with this as well. You get cold starts. That is the main problem. So whenever a function has not been running for a while, it will be shut down. And when it starts up for the first time or after having not been used for a while, it has what's called a cold start. It takes a little time to spin it up and jit it and everything. And that can take, in normal worst cases, a couple of seconds. Which is not a good user experience if I click the button and expecting a reply back. But it can be a perfectly good for an event coming in from another system. If you have uneven or intermittent load, then cold starts may be a problem. If you have an even load, then it probably will not be a problem for you. And there's also improvements being done here. Massive improvements were done with ASP.NET Core 2, .NET Core 2. More improvements and startup times done with .NET Core 3. So when you get functions using .NET Core 3, you'll get more improvements here as well. You can also do the app service plan, which is you pay a fixed fee per second. It's always on. You basically dedicate a virtual machine to your functions. This is not serverless. Now you have a server, you have to care about it. You're responsible for scaling. It can be fitting when you have an even and continuous load, but it's not serverless. Yes. Management of these can be an issue. We have server functions calling functions, calling functions, calling functions, calling functions. How the hell do we keep track of this? Well, application insights can help you a bit. It's nicely integrated with Azure Functions. Gives you things like the application map, showing that we have this thing here that called this thing, that called this thing, that called this thing, and we can tell that this thing uses 108 milliseconds, 43.3 milliseconds delay, and then 17K calls to that. That instance runs for 137.2 milliseconds, 35,000 times. So whenever you're doing distributed computing, logging and monitoring becomes hugely important, especially when you have a loosely coupled infrastructure with events, what happened where, who's dependent on what, and so on and so forth. Any questions? No? Nothing? Okay, we have time to do LogicApps as well. LogicApps is a different serverless service that has a lot of pre-made infrastructure for you. LogicApps is basically this. It is a flowchart programming. And all the developers in the room going, ah. But it's actually pretty nice for some things. So what you can do, what LogicApp has out of the box, it has a bunch of connectors. These are like the some common connectors, functions, service bus, Outlook, FTP, Twitter, Dynamics, SQL Server. It can connect to stuff on-premise, Oracle DB, Postgres, SQL, Teradata, SharePoint, SQL Server, and a lot more of things. Anyone ever use Muhimbi PDF? No? WordPress. Dynamics 365, doc parser, content manager, Salesforce is in here somewhere. A lot of stuff to do with Office 365. There's tons of stuff. And what it basically does, it is built upon HTTP and REST, where you can take, when something happens, you can connect to different resource events. When this happens, take some JSON, parse it. You can have conditions, if, then, and else. We can create flowcharts, connect them together. And we can call different services. And if you have a Swagger or an Open API definition of your service, you can connect it to LogicApps. Functions can be directly integrated into LogicApps. If you create functions, you can make a flowchart saying, when this happens, call this function. When this happens, call this function. And if you get this reply back, then do this, then do this, then do that. And then, and this is the beauty of LogicApps, there's pre-made connectors for a bunch of different SaaS applications, like Dynamics, Salesforce, SAP, although it's not a SaaS application, SharePoint, whatever. So if you want to integrate between different existing systems, this is a pretty cool way of doing it. So when you have a system, something happens there, and you want to update your record in your CRM system, LogicApps can be really useful.
Have you used it professionally?
I have used it in anger, yes. Question was, have I used it professionally? Yes, I have. I've used it to pull down quick way of making a service that pulls down weather forecasting data, sends it to a function to be parsed, and stores that data in Cosmos DB. And it is super easy because I did that in like 5 minutes. So instead of making code of pulling this and sending this, I go in, okay, read HTTP file, because I had a file that was updated, JSON endpoint that was updated so and so often. So I'm going to put on timer trigger every hour, read this endpoint, take this JSON data, parse it, extract these fields, render this function, and store it here. And you do that in like 5 to 10 minutes. Make sure you use LogicApps and not Flow, which is the same thing, just a personal thing. It's sort of like OneDrive compared to SharePoint. Yeah. So, in conclusion, splitting up your application and communicating with events can give you a lot better cohesion and a lot less coupling. Functions as a service can give you some advantages, removing the need for infrastructure code. It can give you a scalable platform that you don't have to care about anymore. It can, in many cases, reduce your costs hugely. Serverless hosting is one less thing to worry about, has some benefits, comes with its own problems. Be aware your mileage may vary, and logging and monitoring is essential. Oh, that was a different talk. So, if you want to get in touch with me, send me an email, ping me on Twitter, or find me somewhere here. Thank you.